In this section, we're going to be talking about linear measure. And we measure linear distance using the units inches, feet, yards, miles, and those are all in our English system. So now I've copied over the conversions for you just in case you need them. Like for instance, 1 yard is equivalent to 3 feet, 1 foot is 12 inches, and 1 mile is 5,280 feet. Now, because we work with the English system, because that's where we live, then these are ones that you should know off the top of your head. But we're going to learn to convert between these units using what's called dimensional analysis. And if you learn dimensional analysis, then you should not have any problems converting within the metric system or between English and metric, because it's all the exact same process. So let's see exactly what we're going to have to do first. Okay, first it says convert 390 inches into feet. Okay, so when we do dimensional analysis, we always start with what we're given. So I'm going to start with 390 inches and I'm going to put that over 1. Now, the key to dimensional analysis is you want to multiply by what's called a conversion factor, and that's these here, how things are related to each other. We don't want inches, so I'm going to put inches on the bottom. And inches and feet are related to each other. I have a conversion factor that relates those two things, so I'm going to put feet on top. Now notice I've not put any numbers in there yet. You always start with putting your units in, and then you fill in the numbers where they belong. For instance, we know that in 1 foot there is 12 inches. Now, because we've set this up using fractions, inches on top and bottom will cancel with each other, and the only units that we're left with are feet. So now it just becomes a simple division problem, and our units are the correct ones that we want to end up with. So now we would just take 390 and divide by 12 to get 32.5 feet. So that's how you do dimensional analysis. And even if it takes more than one step, we can do that also. For instance, here we have one that says, okay, we're starting off with 30 yards. So I'm going to start with 30 yards over 1. And now then I'm going to go and I'm going to put in my conversion factor. I don't want yards, so I'm going to put it on bottom. Now, if you're real savvy, you can go from yards to inches in one step. But let's say that you didn't know that because we didn't have a conversion factor up higher on our page that talked about yards and inches. It went from yards to feet. And that conversion was there's 3 feet in 1 yard. Notice how, again, I put my units in first and then the numbers where they belonged. But I don't want feet to be my final answer. I want inches. So I'm going to multiply by another conversion factor. I'm going to put feet on bottom so it will cancel. And there is a relationship between feet and inches. So I put in my units first and then fill in my numbers. So what is that relationship between inches and feet? Well, there's 12 inches in 1 foot. And now feet will cancel top and bottom, and the only units we have left are inches, which is correct. So now this is just a matter of multiplying 30 times 3 times 12 to get 1,080 inches. Let's see what else we're going to be doing. Well, we're also going to be using the metric system. And the metric system is, it's what's used all over the world. The English system is only used in the United States. The metric system is far better. It's a base 10 system. Once you learn the prefixes, you can move within the metric system easily. But I went ahead and listed here for our linear measure for the metric system, we're always using meters. So everything is, you have your prefixes: kilo, hecto, deca, deci, centi, and milli. Those prefixes go with any measurements. It just so happens that whenever we're talking about linear distance, then we're talking about meters. So that's our original units, or what they call base units. Now, this is the relationship to the base unit. For instance, there are 1,000 meters in 1 kilometer. There are 100 meters in 1 hectometer. There are 10 meters in 1 decameter. There's zero point 0.1 meters in each decimeter, 0.01 meters in each centimeter, and 0.001 meters in each millimeter. So that's our relationship. Now, to help you remember the kilo and hecto and deca, there's a cute little saying that says, kids have dropped over dead converting metrics. So this is kind of a cute little way for you to remember how those prefixes, in what order they are. And because the metric system is a base 10 system, we can actually move very easily between um, kilometers and meters and centimeters and what have you. It's really just a matter of moving decimal places. For instance, if I wanted to say 3 kilometers equals how many centimeters, well, we could just say, okay, look at my prefixes here, and I would have to go from kilo, I'd have to go 1, 2, 3, 4, 5 decimal places. So I would have to take the 3 and move it the decimal place: 1, 2, 3, 4, 5, and filling the rest in with zeros. It technically is very simple, but I'm going to show you using dimensional analysis again, because I want you to see that that works, and it always works. And I want you to get used to doing the dimensional analysis. There are times when you can convert really quickly and easily, but I want you to get the hang of the dimensional analysis, because it's really difficult for a lot of people. So I want you practicing with it. First of all, this problem says convert 30 millimeters to centimeters. So now we could, just move our decimal place over, but let's do this the dimensional analysis way. So we would have 30 millimeters over 1. We don't want millimeters. But remember, in the metric system, everything is, and go back and look at your previous sheet, that previous page, to see how things are related. They're always related to that base unit. And the way that they're related is there's 0.001 meters in 1 millimeter. Now we're not done yet, because we don't want meters, we want centimeters. So again, I'm going to put meters on bottom, centimeters on top, and now the relationship. There's 0.01 meters in 1 centimeter. So that cancels out our meters, and now we can multiply and divide to get our final answer of 3 centimeters. Let's try another one here. Convert 257 meters to kilometers. So we're starting off with what we're given, 257 meters, and we don't want meters, so we're going to put that on bottom. We can go between meters and kilometers, and that relationship is there's 1,000 meters in 1 kilometer. So now our meters cancel out, and if we do the division, 257 divided by 1,000, we get 0.257 kilometers. Another couple to practice with: convert 5 kilometers to meters. So we're going to start off with 5 kilometers. Put that over 1 always. Now we don't want kilometers, so we're going to put it on bottom. And we can go to meters, because there's a relationship between those two. There are 1,000 meters in 1 kilometer. So now our kilometers cancel. And we have 5 times 1,000 would be 5,000 meters. And then finally, convert 40 millimeters. So I'm going to start off with 40 millimeters over 1. It said convert that to meters. So I'm going to put millimeters on bottom, meters on top. We can convert those because there is a conversion factor between the two. There's 0.001 meters in 1 millimeter. And now when I do the multiplication, we get 0.04 millimeters. I'm sorry, meters. Oops. Meters. There we go. Got a little ahead of myself. Alright, so I want you practicing with that dimensional analysis because that will come in handy. Okay, now, but while we're talking about linear measurement or distance, this is a great time for us to talk about perimeter and circumference because perimeter is just the distance around the outside of a figure. So this one says find the perimeter of each shape. So if I add up 3 centimeters plus 3 centimeters plus 3 centimeters, that's a total of 9 centimeters. So that would be my perimeter. Over here, we don't have any numbers. They've just told us we have an L, a length that they call L, plus a width here that they call W, plus another L for length, plus another W for width. So when we put those together, that's 2 lengths plus 2 widths. That's our perimeter formula for a rectangle. Now over here we have a square. So if I were to add these up, I would have side plus side S plus side S plus side S. Altogether, that is 4 S's. So that would be my perimeter there. Now here we have one that could be a little bit tricky because we've got 3 centimeters plus 1 centimeter plus 3 centimeters, but now we change over to millimeters. Now here might be where converting it really quickly using a shortcut might be advantageous to you. We could look at this as kids have dropped over dead converting metrics. And then saying, okay, I want to change all of these, say, to centimeters. That means this 40 millimeters, it starts off at milli. In order to change it over to centimeters, I'd have to move the decimal 1 place to the left. So moving the decimal 1 place to the left would make that 4 centimeters. Doing the same thing here, I would have to move it 1 place to the left, so that would make that 6 centimeters. And now that these are all in the same units, we can just add up each one of the sides. So 3 plus 1 plus 3 plus 4 plus 6 would give us 17 centimeters. Now, from perimeter, it's not a very large jump to go to circumference because when we're talking about a circle, we don't have any sides technically. There's no line segments there for us to be adding up each one of those as we go. But when we look at the distance around this figure, that's the same thing as the concept of perimeter, the distance around a figure. It's just that we talk about perimeter when we have things that have line segments. We talk about circumference when we talk about things that are round or circles. So there are 2 different formulas for circumference of a circle, and they are circumference equals pi times the diameter, or circumference equals 2 pi times the radius. And hopefully you can see why these are, because think about if we have a radius and another radius, that makes the diameter. So a diameter is the same thing as 2 radii. So we can either use the formula using the diameter or 2 radii. Okay, so let's see what they're going to have us do with this. Here it says find the radius of a circle with a circumference of 22 centimeters. Okay, so since they're talking about radius, let's use the radius formula. So the circumference would equal 2 pi times the radius. Well, in this case, they've given us the circumference is 22, and they want us to solve for r, for the radius. So 22 would equal 2 pi times r. In order for me to solve this, I would need to divide both sides by 2 pi. And now those would cancel, and we would be left with 22 divided by 2 is 11 over pi is equal to the radius. So then it just becomes an algebra problem. Find the circumference of a circle with a diameter of 15 feet. Okay, so this time they're talking about diameter, so let's use the formula circumference equals pi times d. They want us to find the circumference, and they've given us a diameter of 15, so I'm going to replace the d with 15. So circumference will equal pi times 15, or a better way to write it would be 15 pi. We generally want pi to come at the end. And then finally, here we have one that says find the circumference of a circle with a radius of 18 over pi feet. Okay, so again, since they're talking about radius, let's use the radius formula. So 2 pi r. They want us to find the circumference when we're given a radius of 18 over pi. So here I've got a pi on top and a pi on bottom that will cancel, and then it just becomes a matter of multiplying 2 times 18, which would be 36. So our circumference would equal 36 feet. Now, last thing is we can also look at partial parts of circumferences, so just a small portion. Just a small portion of that entire circumference would be called an arc length. And it has a formula that says the arc length L equals pi times the radius times the angle divided by 180. So before I do anything, when I'm looking at this problem here, I'm going to go ahead and rewrite that formula so I don't lose that. So that was arc length equals pi times r times the theta, which is just the angle measure, divided by 180. Okay, so our problem says find the radius of the circle containing a 60-degree arc of a circle whose length is 11 pi meters. So they've given us length is 11 pi meters, and they've also given us a 60-degree angle. That's our theta. So if I plug in what I know, in place of L, I'm going to put in 11 pi equals pi times r. Instead of theta, I'm going to put in 60 divided by 180. And now we can solve that for r just by doing algebra. 60 over 180, that will reduce down to 1 over 3. So now I have 11 pi equals pi times r divided by 3. And I'm trying to get r alone, so how about if I get rid of this division of 3 by multiplying both sides by 3? So when I do that now, I have 3 times 11 pi, which is 33 pi, equals pi times r. And if I now divide both sides by pi, we get r equals 33. So that would have a radius of 33 meters, since this was being meters.